How do you identify the correct theorem for Euclidean geometry proofs? Imagine you're trying to solve a puzzle, but you need the right piece to complete it. In Euclidean geometry, that piece is often a theorem. Knowing which theorem to use can feel tricky, but with a few simple steps, you can match the right one to your problem every time. First, look carefully at the figure. Identify all the shapes involved, like triangles, circles, or polygons. Notice any given information, such as equal sides, angles, or parallel lines. This helps you understand what you are working with. Next, recall the fundamental theorems related to those shapes. For triangles, think about theorems about congruence or similarity. For circles, consider theorems about inscribed angles or chords. If the figure shows right angles, the Pythagorean theorem might be useful. When you see specific conditions, like two sides being equal or lines being parallel, check if they match the hypotheses of known theorems. For example, the side-angle side theorem requires two sides and the included angle to be congruent. Confirm that these conditions are present in your figure before applying the theorem. It's also helpful to use basic axioms and postulates, like the fact that through any 2 points there is exactly one line, or that parallel lines never meet. These foundational ideas support many theorems and help guide your reasoning. Look for familiar patterns or configurations. For instance, if you see a right triangle with a square on its hypotenuse, the Pythagorean theorem is likely the best fit. If your goal is to prove that two angles are equal, consider theorems about alternate interior angles or corresponding angles if lines are parallel. Sometimes breaking down complex figures into smaller parts makes it easier to find the right theorem. Divide a complicated shape into triangles or rectangles, then apply theorems to those simpler parts. For example, decomposing a polygon into triangles allows you to use triangle congruence or similarity theorems. When you connect the given information with the conditions of a theorem, it becomes clear which one to choose. This logical process helps you build your proof step by step. Remember, the key is matching the conditions in your figure with the hypotheses of a theorem. By doing this, you can confidently select the correct theorem and make your proof clear and solid. Practice this approach regularly, and soon identifying the right theorem will become second nature.